Okay, so for the next part, we're going to be looking at some word problems. So we're going to be looking at what's called projectile motion. So for this, there are some formulas that we're going to need. So most of the time they just give you the parametric equations, but if they don't, you will be given these formulas. So to make our horizontal distance equation, or our x equation, it's going to be t as in the variable, times v naught. V naught is going to stand for our initial velocity, times cosine theta, and theta is going to be our angle that the object is launched. Then our vertical position, which is going to be our y equation for our parametric, is t times v naught sine theta minus 1/2 times g. So g is representing gravity here. A lot of the problems we're going to see are going to be in feet per second, so we're going to use 32, but you just have to look at your units to see which one you're going to use. And then times t squared plus h naught, which is the initial height, and then t does stand for time here. So like I said, they will either go ahead and tell you the equations, or if they don't, then you will make your equation, but you will be given these formulas. Okay, so you're going to need your calculator for this. So we're going to see how this is going to work. So Kevin hits a baseball at 3 feet above the ground with an initial speed of 150 feet per second at an angle of 18 degrees with the horizontal. So we're going to, for part A, write a set of parametric equations. So we have at the top the formulas that we need. So from this, we know that v naught, which is our initial velocity, is 150 feet per second. We also know that the angle is 18 degrees with the horizontal, and it says he hits a baseball at 3 feet above the ground, so that means our initial height, or h naught, is going to be 3 feet. And we are working with feet per second, so when we do our gravitational constant, we need to use the feet per second one, so the 32 feet per second squared. Okay, so to write our set of parametric equations, for x, it is t times v naught, which is 150, cosine of the angle, which is 18 degrees. So a lot of the times with these, you'll see that the t is written second. So I'm going to write this as x equals 150 cosine of 18 degrees times t. So that is our x equation in our parametric equations. And then for y, it is t times v naught, which is 150, sine of theta, which is 18 degrees, minus 1/2, g we're using 32 because of the units, t squared, plus our initial height, which he started at 3 feet, so that's going to be 3. So if we want to clean this up a little bit, we could write 150 sine 18 degrees t, and then this would be minus 16t squared plus 3. So those are our parametric equations. Okay, so then it says, how far away will the baseball land? So guys, think about if you are throwing a baseball, how far away is going to be your horizontal distance there? So this is asking for the horizontal distance, which is, what is x? Well, in order to plug in for x, we're going to need the time. So we're going to need to know, when does this ball actually hit the ground? So what we're going to do here is we are going to use our y equation, and we are going to set the y equation equal to 0. The reason, this will tell us if y is equal to 0, that means that the height is equal to 0, which means this will be when the ball hits the ground. So if we can figure out how long it takes for the ball to hit the ground, then we'll have our time and we can plug into x. Okay, so our y equation is 150 sine of 18 degrees times t minus 16t squared plus 3, and we're going to set that equal to see when it hits the ground. So we're going to put one side in y1 and one side in y2. Now we are not using the parametric equations to do this. So in your calculator, make sure your mode first off, make sure it's in degrees. And then we want to just change it back to function. So when I go to my y equals, we're going to type this in. Just be careful with your parentheses. So 150 sine 18 degrees. We have our x. And then minus 16x squared. And then plus 30. And then you're going to make sure you have 0 in your y too. So we'll just graph and see what's going to happen. Okay, so we do have this parabola shape. I'm going to draw a picture on here. So it does go up and then it hits the ground. So we want to find this time right here where it hits the ground. So we're going to do second trace and we're going to do intersect. And I'm going to move it closer to the other point. So I'll have to do it twice. So right there is close enough. And you're going to enter 3 times. And make sure it says intersection. So my t value there is 2.96. And that would be seconds. So at 2.96 seconds, that is when the ball will hit the ground. So the question asks for how far will the baseball land. So we're trying to figure out what is the distance. So this is where we're going to plug into x. So we know the x equation is 150 cosine of 18 degrees times t. So we're going to do 150 cosine of 18 degrees, and we're going to plug in for t 2.960. So we plug this into the calculator, and we're just plugging in this into the regular part here. Making sure we're in degrees, but we're going to have 150 cosine of 18 degrees, and then that's times 2.960, which is going to give us 422.269. And that is the distance, so that is going to be in feet. Okay, so we used our parametric equations here. We made an x equation and a y equation using our formulas, just plugging in. And then because it said how far will the baseball land, we wanted that horizontal distance. Well, before we had to do that, we had to figure out how long it was in the air for before it hit the ground. So we had to use our vertical distance. We knew when the vertical distance was 0, that's when it hit the ground. So we figured out the time, and then we plugged that time in. Okay, so if we look at the next problem, it says Kaylee shoots a basketball with an initial velocity of 24 feet per second. So we know our V naught is 24 feet per second at an angle of 53 degrees. So we know that our angle is 53 degrees from a height. So our initial height is going to be 4.75 feet. If Kaylee is 13 feet from the base of the basket and the basket is 10 feet in the air, will she make the shot? So we're saying she's 13 feet from the base and the basket is 10 feet in the air. So we're trying to figure out if that ordered pair 13, 10, is that going to be a true statement? Is she going to hit that basket when she's 13 feet away from the base based off this equation? So we're going to make our equation. So we're using the formulas for the horizontal distance. So what it says is it is V naught, which is 24, cosine of the angle, which is 53 degrees, times the time. So there's our x equation. And then our y equation is going to be 24 sine of 53 degrees times t minus 1/2 times 32, so that's going to be minus our 16t squared, just like the last problem, and then plus our initial height, which is 4.75. So we plugged in just like we did our last one. So there's our set of parametric equations. We want to see if this x coordinate and y coordinate are going to work. So what I'm going to do here is I'm going to plug in x to get the time first, kind of like we did earlier the problem. So I'm going to take this x equation, and if x is 13, that would be 13 equal to 24 cosine of 53 degrees times the time. Okay, so if we solve this for t, this is 13 divided by 24 cosine of 53 is equal to t. So in our calculator here, so I'm going to make a fraction so it can look like this. So I'm going to do 13 over 24 cosine of 53. And this gives us the time is 0.900. Okay, so what we're going to do next is we're going to take this time that we just figured out and we're going to plug it into the y equation to see if it gives us 10. So we know y is 24 sine of 53 degrees times the time, which is 0.9, minus 16 times 0.9 squared plus 4.75. Let's move this over. Okay, so if we type this in the calculator here, this is going to let me, it's not going to let me move it over. Okay, it's good. So if we type this in the calculator, this is going to be 24, I'm going to do my parentheses like this, 24 sine of 53, close the parentheses, and times 0.9, minus 16 times 0.9 squared, and then plus 4.75. So this is going to give us 9.041 feet. So that's saying when she shoots the ball from 13 feet that the ball's only going to go up to a height of 9.041. Well, the basket was at 10 feet. So she is not going to reach the basket. So Kaylee will not make the shot. And we could say because the basket is at 10 feet, and her shot only went a height of 9.041 feet. So it's just like those problems where it asks you if this coordinate will work. That's all we're figuring out. Just does that y value make sense there? Does that y value work here? And we figured out from this that it does not work. Okay, because she only shoots it at 9.041.